Okay, here's some answers for those that are done. Feel free to check.
I almost got them all right.
Feel free to check with your neighbor. Ask me. Be happy to help. Not question?
I got them right, but this is the right way to do it.
Is it the right way to do it?
Yeah.
Oh, 4 looks pretty good. 3. So I'm kind of curious how your -3 magically becomes positive 3.
Or you like
got
a
a
negative.
-3 and then there's whammo, all of a
So we
sudden
like
positive.
a -3, negative x.
So it should be, right here, it really should be a positive 3 actually. Yeah. The first one's fine, second one, you can dust it. Second one looks good. Yeah, it's real good.
What's the score? Your soccer team got 1 point, please? Oh, that's right, you play hockey. Question. No, I'll look at your hands.
Oh, sorry.
Okay.
No hand.
I got everything right but 3.
Hey, just walking around, peeking over shoulders. It looks like there was some good success, but maybe you missed one, or maybe I was talking to Doc. Doc got every single one of them right, and he said, "But does my work look good?" I think that's a nice question. Anybody have any other? His work looked good too, right?
I got 3 wrong.
Number 3 wrong?
Yeah.
Okay, let's look at number 3.
I think I just did it in the wrong way.
Okay, let's find out. So we'll just kind of compare notes here and see. So as I look at number 3, the first thing I see is 2 different distributive properties.
Yeah, -3.
-3 gets distributed. When I do that, let's double check this one really carefully. -21 is actually plus,
Oh, that's what I want.
because a negative times a negative gets you a positive. Yep. So then the 8 would get distributed. So you get 8x squared minus 8. So it was probably that plus 3x, wasn't it?
That's what I want.
Okay. Okay, cool. Easy mistake to make, but also an easy one to fix.
Yeah.
Okay. What else can I do to help you guys?
I got the other
Nice. That's good. And now you have a better sense of this
Yeah.
one. You got a good shot at getting 4 out of 4. So that's awesome. Very good. Okay. You seem settled. So let me ask you all a question. How's equation solving going? Like with your web assigns and all that stuff?
Yeah.
Any hiccups there? Has it been going okay? Bien, you said?
Yeah.
Ah, muchas gracias.
See.
Okay. Well, the good news is what we're going to do today is more solving of, today's going to be inequalities, but more of the same sort of practicing. Ellie.
I have a question, because on the homework, when we actually graph it, it says it needs the Adobe Flash Player, but I can't get it.
Yeah.
Yeah,
So I
I
just
did
had
that.
to turn it in.
I
You
just
did wrong.
yeah, I can't get that. I did it on my paper.
I did the graph, yeah.
Yeah, I'm just doing it wrong.
I have to use a different, like a little browser.
Yeah, I'm going to show you something. And I don't know if this is going to do this for me or not. Okay, so what was last night's? Was it 2?
Yeah, they do.
Homework, Unit 2, Homework 2? Okay. So I might have a good answer for you. Unit 2, Homework 2, view.
It was the last question.
I don't want the key. Go away. Okay. The last. Okay. So is that what you're seeing?
Yes.
So I think I have an answer for you. Hopefully. So it says flash blah blah blah. So what I'm going to do is I'm going to come back to like the main WebAssign screen. Do y'all see? Can you see my mouse?
No.
Can't. Oh, doggone it. Okay. So I'll do it this way. Can you see? I think this will work. We'll find out in a second. Do y'all see this lock up there?
Mm-hmm.
So I'm going to click on that. Okay? So if I click on the lock, see what it says? Flash, block, default. So the default is to block flash. I don't know why. So what I'm going to do is I'm going to click on this little box, I'm going to allow it, and then I X out, and then do you see how it requests that I reload?
Yeah.
I'm going to reload. Okay, so now let's look. See if this worked. Usually this is what does it. So score, no, I don't want scores. I don't want that. I want, that's just view. There we go, view. So, bing, look at that. It's there. Okay, so if you get that message, every now and then somebody will do all that couple of clicks there and get it all like it should work, and then there's still some issue. Sometimes you just need an update on your flash, but I'd say probably 9 times out of 10 or 19 times out of 20, it's click on the lock, allow flash, and it should work. Is that good? Thanks for asking. Okay. Otherwise, maybe okay? Okay, cool. So let's do a little work with our equations. I will try to get there myself. There we go. So yeah, we'll do, I don't know, we got a bunch of them we can do, like 6 or 7. We'll just see what we need to do. Okay, so we'll start here. I'd like to get some thoughts from you guys to see how you're all doing, because I feel like this is our 3rd day doing equations and inequalities. There's going to be one new kind of looking thing today, but a lot of this is going to be very, very similar. So I'd love to hear from you, partly for me to kind of understand how you're all doing with this. So if you did look at number 1 on practice 1, does anything strike you all as maybe being something we need to take care of maybe right away? Yeah, there's an X on both sides. So as you guys know, a lot of times I like to draw like a little fence right down the middle where either the equal sign or the inequality symbol is, either one of those. And Ellie's right. There's an X on the left side and there's an X on the right side. And I really think that we should try to deal with that before we do anything else. So what do you suggest? What would be a good move? Mason, what do you think to do with it? Deal with that. Put the negative 4x with the 2x. So, but how, am I allowed, I agree. So Mason, I totally agree. I think I want to handle the minus 4x. I think that's the right idea. But am I allowed to just sort of just walk it over there? No. I can't. So that blue line it's the relationship fence, if you will. You can't just move things over there just because you feel like it. You need to deal with it mathematically using some of the properties we looked at last week. So Mason's right. We want to deal with that negative 4x, but how could we do it in a way that's not just picking it up, copying and pasting it on the other side? Because we can't do that. Sophia?
You could add 4x.
Why on earth would you add 4x to both sides?
Because then it cancels out on one side.
Because right now as it stands, it's minus 4x, right? So adding 4x, I don't know if that's quite genius level, but that's the right move, isn't it? Okay. Mason's giving you a lot of credit over there. That's good. Okay. Does that move make sense to you all? Like he said, we want to move that over there to the left side, but we can't just copy and paste it. We need to mathematically move it, and that's a way to do it. Okay, so if I do that, I get 6x minus 9 is greater than, what's left over on the right side after we do that?
21.
Just a 21, right? Because 4x, a negative 4x plus 4x is just 0. So we got 21. Okay, this is a nice place to be, but we're not done. The x is not by itself. Doc, suggestion?
Add 9 to both sides.
I think that is an excellent move. That'll start to clear out the items that are with the 6x. So if I do this, over here I get 21 plus 9 is 30. Doc, what would the left side look like after I did that?
6x.
Just 6x, that's right. So I'm going to bring it all the way over to here. 6x is greater than 30. We're almost done, aren't we?
Yeah, but you have to find that
I got to get the x by itself, and I'm not quite there yet. Kate, any suggestions of what I could do?
You could divide by 6 on each side.
I think that is an awesome idea. Okay, so when I do that, 6 divided by 6 is 1, so I just get 1x is greater than 30 divided by 6 is 5. Okay. So how many numbers are bigger than 5? Lots of them, right? So that's why we will graph these, right? So we can kind of express the answer in a visual way instead of just an analytical way. So I need to do something to the 5 on my little number line. What do I need to do to the 5? What needs to go there? A circle. Should the circle be an open circle, like an empty one, or should it be filled in? It should be empty, yep. So empty circle on 5. And then we need to draw an arrow one way or the other. Should the arrow go to the left side or to the right side? Why would you pick the right side? Yeah, we're looking for numbers bigger than 5, and all the numbers to the right side are bigger than 5. Yeah, well said. So I draw an arrow that way, and I'm good. Why? Under what circumstances would I have a filled-in circle? Because right now it's open. What would I need to see? Yeah, if the inequality was or equal to, right? If you use a little extra ink on the inequality, you got to use a little extra ink on the circle. Fill it in. We'll see one of those here in a little bit. Yes, sir.
So if it wasn't equal to, but it was less than, it would still be open?
Yeah, if it's just less than, or if it were greater than, it's open. But if you throw the extra line on there, like Sophia said, fill in the circle. Yep. So, as you guys know, on WebAssign, they do ask you at times to do this interval notation thing. Anybody have any idea what the interval notation version of this answer would look like? I know this is like a little bit different. This is actually nice to get you ready for Algebra 2, pre-calculus, whatever it is later on. What do you think, Ellie?
Would it be the 5 comma z, like infinity?
5 comma infinity is right. You always put low number, comma, high number, and you can see there is no high number, right? It just keeps going and going and going. But then we have to either put parentheses or brackets on the outside. What do you think we would use here? By the 5, you think of parentheses? Okay. And then we will always put a parentheses around or on infinity because you can't actually count to infinity, right? Just saying that we keep going forever and ever. Why would you pick a parentheses for the 5? What would encourage you to do that? Say, go ahead.
Because it's open?
Say again?
Because it's open?
Yeah, the circle's open. Open circle goes with parentheses. Filled in circle goes with bracket. And I think we'll see a bracket here in a second. All right, so how do you feel about that one? Using all the same equation solving skills, we have the added little piece at the end with the graph and the interval notation. All right. Well, let's take a look then at number 2. Excuse me. Oh yes, number 2, this will be a good one, I think. Yeah. Okay, please take a look at number 2. And I want you guys to try this for a bit on your own if you haven't already looked at it. An interesting one, for sure. So let's take a look at number... Does this one have like 2 inequality symbols?
Yeah.
Okay. So, there we go. Number 3. This will be a little bit different. It's 2 statements in 1. Okay, so number 3. Y'all know what a compound sentence is? Isn't it 2 like complete thoughts joined by a conjunction? Or maybe I think it's a conjunction, like the word and. Like, so here's an example of a compound sentence. Hey Noah, I need you to take the trash out and clean up your room. Anybody ever gotten yelled at about taking the trash out or cleaning up your room?
Yes.
So maybe your parents have said that.
Yes.
I need you to clean up your room and take out the trash. Those 2 things are not necessarily connected, are they?
No.
You might just need to get your clothes off the floor and get your dirty clothes. Goodness, Trevor. Trevor. Do I really have to tell you that that's a poor choice? Mason. Yeah. I just want to let you know, hey, Trevor, Mason, I have like absolutely no patience for that kind of thing. None. No patience. It's not 3 strikes you're out. It's just typically 1 strike you're out. Because I'm here to teach. I'm not here to whatever. Okay? Cool. So, like if you were told you got to clean up your room and take out the trash, those are kind of 2 separate thoughts, aren't they? But the word "and" kind of tells you that you got to do both. Right? Mm-hmm. So this is kind of a compound sentence. So this is saying that negative 12 is less than that expression in the middle, and that expression in the middle is less than or equal to 27. So do you see how it's kind of 2 different statements sort of smashed together into one?
Yeah.
So since it's 2 different statements, we're going to have to deal with this a little bit different, but I think you'll find this to be pretty intuitive. But let me ask you a question. I don't know how you're going to handle this. When you look at this, the first thing you see is what? Like what jumps out at you is like, I should do that. What do you see, Mason?
Parenthesis thing?
What? Yeah.
Times X and
And when he says the parentheses thing, what is he talking about? Distributive property, right? Let's multiply the 3. This will work fine. So maybe my next statement would be negative 12 is less than 3x minus 3, which is less than or equal to 27. Just distribute the 3. So when you have a situation like this, don't you sort of have 2 fences? 2 fences in this statement. So this will be a little bit different. Okay, looking in the middle there, we're trying to get the x by itself. That part hasn't changed. Would you guys get rid of the 3, or would you get rid of the minus 3 first? The minus 3, yeah. So how do I get rid of something or other minus 3? I add 3. So I'm going to go plus 3. But then, aren't you supposed to do it to both sides? But what's weird about this is there's not like 2 sides, there's like 3 sides, aren't there? Hang on just a second, let me finish my thought. Well, I'll get your question in a second. So if I add 3 to the expression in the middle, I have to add it over here on the right side, and I have to add it over on the left side. So since it's kind of a 2 sentences put into one, whatever I do to that middle part, I've got to do on each side of the fence, essentially, right, to keep this balanced. And Ellie, your question was?
Oh, couldn't you just like get rid of the 12 at the very start?
What do you mean get rid of it? Like erase it?
Like plus 12 and then do that.
Okay, well can we come back to that?
Yeah.
I want to finish this thought and we'll come back to that. Because the answer is, Ellie, yes you can, but you might get an unexpected result. Okay. So over here on the left, negative 12 plus 3 is negative 9, is less than, what do I have left over in the middle now?
3x.
Yep, just a 3x is less than 30. So the x is clearly not quite yet by itself. What do I need to do to get it by itself, Sebastian?
Well, I had a question.
Okay, let me get this part taken care of first. What do I have to do?
Isn't it less than or equal to?
Oh, sorry, I lost my equal to.
Yes.
How do I get the x by itself? Yeah, sorry about that. Divide by 3, right? The hard part is, of course, if I divide this by 3, I might question, well, which of the other ones do I divide by 3? The answer is both of them, all of them. Divide all 3 parts by 3. Then I get to this, negative 3 is less than x, which is less than or equal to 10. So it is a compound statement here. Hopefully that makes sense on how we deal with this. Now, we're going to graph it. So clearly negative 3 and 10 are important to this question. Anybody have any ideas on what feature would go at negative 3? The open circle, yes. And then how about on 10?
The closed.
It's a closed or a filled-in circle, yes. Okay, so we're looking for numbers that are bigger than negative 3 and at the same time less than 10. What are we talking about? If the numbers are bigger than negative 3 and at the same time smaller than 10, it's in between. Yes. So what we do is we would just connect these two with a little line segment there. It should be straight. Mine's a little crooked, but whatever. And that would be our graphical answer. Any guesses on an interval notation? I'll get your question in a second. Any thoughts on an interval notation answer here? What always goes with an open circle? Parentheses. Yep. Okay, what always goes with a filled-in circle? A bracket. And then don't you go low number, comma, high number? -3, comma 10 with the parentheses and the bracket where they are. Okay, so can I go, are you okay with that part so far? Mason, you're good?
Yeah.
Okay, because you had your hand up a second ago.
Yeah.
You're good? Okay. So can I go back a little ways and address Ellie's question? Because she said at the very start, and I think your question is good, I just didn't want to do a, and have to come back. Can we go back and address that real quick? Because she said, hey, couldn't we just do this? So let's talk about, couldn't we just do that? So I'm going to leave my graphical answers up there. I'm going to come back over here, and I'll reset my fences right here and right here. Ellie, will you say again what you proposed?
I don't remember.
I think, now you tell me if I'm wrong. See if this rings a bell.
Oh,
Oh,
wait,
plus
I
12.
remember. Okay.
I think that's what
Couldn't
she
you
said.
just add 12 so that you could just get rid of the time of
So let's see here. I think we got to here, and then you said, hey, couldn't we just do that thing with the 12?
Mm-hmm.
Okay, so let's talk this over. The short answer to your question is yes, you can, but I think the thing you're hoping that will happen doesn't happen. So check this out. If I go plus 12, don't I have to go plus 12 here and plus 12 there? Okay, so let's think about what results. 27 plus 12 is 39. -3 plus 12 is 9. And I think this is what you're hoping would happen. But what's -12 plus 12? It's not blank, it's 0. So you actually get this. And there's nothing wrong with this. In fact, I'll show you in a second, you get the same answer. But getting a 0 over there on the left side, unfortunately, does not make that inequality symbol go away. It just means you got a 0 over there.
Oh, okay.
So if we did do this, let's think this over. If we did do this, and we're trying to get the x by itself, what would you do next? -9. We do that from all 3 parts. So I'd get -9 is less than 3x, which is less than or equal to 30. My final step, divide by 3. Yeah, and can you see how we're going to get to the exact same place? So this would be -3 is less than x, which is less than or equal to 10. And whoa, look. So you know how it is, right? Isn't there more than one way for you to get to your house?
Mm-hmm.
Come on, sure there is. My daughter asks me all the time, like, Daddy, if we turned that way, could we still get home? And isn't the answer almost always, yeah?
Mm-hmm.
Because there's always a way to get back on course, usually, right? Unless you just go to a dead end and don't know how to turn around. So this is an example of, I went this way to get home, and Ellie's suggestion was kind of like, well, let's go over here first, and then we'll go back home, right? It is totally okay if you have some little detours along the way, as long as you don't break any math rules, as long as you don't say anything that's false. It's okay. You take a little detour over here and you go see, a friend, or you go stop and get some food, and then you get home. That's okay too. Do you get the analogy? It's totally okay. Thanks for asking, Ellie. And by the way, I love it when you guys ask what if, or why couldn't we just do that? Those are great questions. Great questions. Thanks for asking. Really appreciate it. Anybody else? Mason? Okay, cool. We have 6 minutes, and I want to pick one out, and I think I know what I want to do. So we're going to flip ahead here. Please check out, what do I want to do? Oh, yeah, I want to do this one. Please check out number 2 in practice 2. Number 2 in practice 2. Practice 2, number 2. This is really similar to the one we just did. So that's why I wanted to do this, because this one is probably the least familiar. So let's take 4 minutes real quick. Do as much as you can. I'll show you an answer. Hopefully we'll all leave on a happy note. Well, it just popped into my mind. Keep in mind that, I guess it's 1 week from tomorrow is your Unit 1 test. from tomorrow. So that means you have 1 week from today, essentially, to get any concept quiz retries completed that you want to do. Okay? Basically, have 7 days, 7 calendar days to get those wrapped up. Please very much consider, as I mentioned at the very start of the year, the #1 indicator of success in this course was performance on concept quizzes. Like, in other words, if you eventually got really good at concept quizzes, the tests weren't very hard. If you never put in the work on the concept quizzes, whether it was on the front end or the back end, the tests didn't go as well. Okay? So if you need to do a couple of retries on some concept quizzes, I encourage you to do so. It'll help your grade, and it'll help your test later on too. So kind of a win for everyone. I think, yeah, you can distribute to 7, so 7 times -2 is that, but we should have 7 after this. I think she's about to jump. Right, yeah, so we're going to graph variable notation.
Wait, and so they're both brackets, right?
Yep,
Yeah.
that is true. Okay, I am quietly working up here. Hopefully to get to a good answer. So there's my analytical answer up there. What do you think? -2 is less than or equal to x, which is less than or equal to 2.
Yes.
Okay? So then when you actually put this on a graph, what kind of features would show up on the -2 and the 2?
Close.
They're both the same, aren't they? They're both closed circles? Yeah. So fill it in the circle there and fill in the circle there. Ella, how would I finish this? Because I'm not quite done yet, right? As far as the graph.
By drawing a line in between.
That's right. We're talking about all the numbers in between, so make sure you include that. So all those numbers, so like 0 is going to be a solution, -1 or 1, all the little fractions in between, all those numbers would work. Isa?
So could -2 and 2 also work for this?
Yes, because of the or equal to.
Okay.
If they were open circles, we're saying they don't work.
Okay.
Yep, good. And then interval notation, did you guys go double bracket?
Yes.
-2 to 2 with a double bracket. Hey, one last thought before you guys go. You did really, really good today. If I remember correctly, please look at the screen. If you're looking at anything other than the screen, you're looking at the wrong thing. Don't look at my face. Don't look at your book. Look at the screen. So if I remember correctly, for tomorrow, there is an intro video, and it is on this topic right here. I think it's like 5 minutes long. It's on functions. Okay, it's on functions. So click through on your Schoology to the Ed Puzzle video for this. And tomorrow and Monday, actually, we're going to be talking about functions, or tomorrow and Tuesday. So anyways, have a great day. Don't forget the intro video. So you need to have 4 classes. When you come to class, I'm going to say, hey, we're going to talk about functions. So what you learned in the video, and we're just going to start trying to use that stuff. So before class starts tomorrow. Good job, you guys. Appreciate your hard work.
Thank you, Mr.